I'm Xuelian Li and I'm doing the first question of homework 10 of the probability and the stochastic. The first question is collect the definitions of the simple properties of the following process. The first is Poisson process. And x of t means counting the numbers of occurrences of an event in time 0 to t. And we can use this Poisson process in the following events like arrival of calls and arrival of customers and queuing theory and so on. And the probability message it equals e to the minus lambda t times lambda t of k over the factorial of k, and the mean it equals lambda t, and the autocorrelation equals lambda squared times t1 times t2 plus lambda times minimum of t1 and t2. And from the mean of function of Poisson process, we can get Poisson process is not wide sensation process, and it has other properties like x of t2 minus x of t1. It can be viewed as Poisson distribution when suppose t2 bigger than t1. And the second property is x of t2 minus x of t1 and x of t4 minus x of t3 are independent. And the last is Poisson process satisfies the Markov properties. And the second process is Poisson increments. Let's define the y of t equals x of t plus c minus x of t over c. And x of t can be viewed as Poisson process, and the parameter is lambda and c is fixed. So the probability mass it equals e to the minus lambda c times lambda c to the n over factorial of n, and n equals 0 to 1 to 0, 1, 2, and so on. And the mean equals lambda and autocorrelation. There are two situations. First, t1 plus c smaller than t2, it equals lambda square, and when t1 plus c bigger than t2, it equals lambda square plus lambda square over c minus lambda times t2 minus t1 over c squared. So when t1 plus c bigger than t, the autocorrelation only depends on tau, and the mean value is constant, so Poisson increments is wide and stationary. And the third one is normal process. We've already learned that if x and y jointly normal, and x and y can be viewed as Gaussian process, and they mean is mu1 and mu2, and their variance is sigma 1 square and sigma 2 square, and the rho is their correlation coefficient. And the stochastic of a normal process is fully determined by e of x of t, and it equals eta of t. And the autocorrelation only depends on t1 minus t2. So we can get the normal process is strict and stationary. That's all. Thank you.